connection of angle section to gusset using fillet well. So this is the angle section which is connected to the gusset plate using longitudinal fillet wells of length L1 at the bottom and L2 at the top. Say this is a CG of the angle section, then it is at a distance of x1 from bottom and x2 from top. Length of the weld will be total, that is L1 plus L2. In order that no moments get transferred, moment about CG should be 0, that is moment of top weld about CG will be equal to L2 into its distance is x2, that is equal to, whereas moment of bottom weld will be L1 into its CG distance is x1. Then using these two equations 1 and 2, we can find L1 and L2. The other case is when weld is provided all around, say L1 is length of top weld and x1 is CG distance from top and x2 is CG distance from bottom and L2 is bottom weld, then total length of the weld will be equal to L1 plus x1 plus x2 plus L2, whereas moment about CG should be 0, that implies L1 into its CG distance is x1 plus x1 into its CG distance is x1 by 2, which should be equal to L2 into CG distance is x2 plus x2 into CG distance is x2 by 2, and that is L1 x1 plus x1 square by 2 should be equal to L2 x2 plus x2 square by 2. Using these two equations, equation 1 and 2, we can solve for L1 and L2. Few codal provisions are: when end of an element is connected by only parallel longitudinal fillet welds, then there should be an end written of 2s to be provided to the length of the weld, where s is size of the weld, s is size of weld, and 2s is called as end written. This is specified as per clause 10.5.1.1 of IS 800/2007. Whereas when only longitudinal fillet welds are provided, then say L is the length of the weld, then length of the weld should not be less than B, where B is transverse spacing between the fillet welds, that is the center to center spacing between fillet welds along the transverse direction. If it is B, then length of the weld should not be less than B, and minimum lap is given as maximum of 40 or 40 mm, where T is thickness of thinner connected plates. This is as per clause 10.5.1.2. Whereas the effective length of fillet weld, which is denoted as LE, is a length calculated corresponding to the size and provided throat thickness, but whereas in practical the actual weld length is in excess of effective length, that is LE plus 2 times of S for each end, and this actual length of weld should not be less than 4 times of S, where S is size of weld. This is as per clause 10.5.4.1, whereas in case of intermittent welds, as per clause 10.5.5, the effective length of intermittent welds should not be less than 4 times the size of the weld, and the minimum length of the weld should be 40 mm. This is the length of the weld and it should not be less than 40 mm. If say S is the gap between the provided welds, then there are specifications for S, that is as per clause 10.5.5.2, S should not be more than 12T or should not be more than 200 mm in case of compression members, whereas the same S should not be more than 16 times of T and not more than 200 mm in case of tension members, where T is thickness of thinner member. And the design of slot or plug welds is same as that of fillet weld design. But the effective area of slot or plug welds is taken as pi by 4 times the diameter of the plug or slot provided. So then the design strength will be equal to area, that is pi by 4 d square, into stress, that is Fu of weld by root 3 into gamma mw. Root 3 is, since it is shear strength, then root 3 should be provided.